Hello students, welcome to Distinction Learning Platform. In this video, we'll be looking at ionic bonding and chemical bonding. But before we begin our lessons, make sure that you subscribe, like the video, as well as comment in the comment section. Alright, let us begin. So, just to recap, we talked about chemical bonding in the previous video, which is in the introduction video. We said that chemical bonding or bonding, basically, it's just a chemical combination of atoms in order to form compound. And remember, how many types of compound we have? We have two types of compound. We have ionic compound, which is characterized by what? Having a non-metal and also a metal atoms. Then what about the molecular compound? We said molecular compound, we have now non-metal atoms that are what? Chemically reacting with one another. That's what we talked about, alright? Make sure that you watch that video. Let us begin. So now, what is ionic bonding? Ionic bonding basically is a type of bonding where, so we're saying, what is ionic bonding? So ionic bonding, we're saying type of bonding, okay, type of bonding where a metal atom loses electrons, okay, and transfers to the non-metal atom. Okay, that's the first definition that you need to understand, is that ionic bonding is the type of bonding where a metal atom loses electrons and transfers to the what? Non-metal atom. Okay, so what do I mean? So let us illustrate what we're talking about here. So let's say we have a certain metal here. Okay, we have a certain metal here. I'm just giving an example. We have a certain metal which is maybe sodium. So let us use sodium. We have certain element which is what? Sodium. Okay, and we have a non-metal here. A non-metal which is maybe oxygen. Because we are saying that ionic bonding is going to exist between a metal and the non-metal. Okay, but how does ionic bonding happen or occur? So this metal will start losing. So this metal will start losing what? Electrons. So electrons, I'm just going to represent them as E. Okay, so these metals are going to be losing this electron. Wonder we said metal atom loses electrons. So they are going to lose these electrons and transfer to what? A non-metal, and transfer to the non-metal atom. So these electrons that are coming from here, they are going to be transferred to the what? To this non-metal, which is the oxygen. And this type of bonding, we call it ionic bonding. That's a very, very important point that you need to take note. Alright? Now, we need to put another important point here, is that ionic bonding is going to exist. So we're going to say exists between a metal and a non-metal. Take note of this point, okay? So ionic bonding exists between a metal and a non-metal. As you can see, this is a metal and that is a non-metal. Always you need to make sure that you know about that, okay? That's all about the ionic bonding. Okay? Now, we need to understand how we can now look at the atomic structure of an ionic compound, because when a metal and a non-metal react with one another, they are going to form a type of compound which we call ionic compound. Now, let us look at how this bonding happens. Okay, so let us look at a good example of this bonding, or of this ionic bonding. So a good example. So let us look at a good example. So they are going to ask you to show the first good example. Let us start with what? First good example. They are going to ask you to show the ionic bonding that's going to exist between different atoms like this. So they are going to ask you to show the bonding between. Okay, so let us use group 1 elements between. Let us use sodium. I like sodium. Between sodium and oxygen. Atom using this, the star and the dot symbols like that. Okay, using the star and the dot symbols like that. Okay, so these are the things that they are going to ask you. So we need to understand how we can show the ionic bonding of different atoms. So I'll start with this like simplest question. Then as we are going to other questions, it will be difficult like that. Okay. Now, how are we going to show the bonding between sodium and oxygen? So make sure that you need to start now following the steps that you need to that you need to know, and they are going to help you during an exam. The first step that you need to understand is that what we've been asked is to show the ionic bonding between sodium and oxygen. Okay, so we're going to show this one. So now, how are you going to show this one? We need to make sure that you form the chemical formula for sodium and oxygen. So they are telling us from here, because remember what I said, bonding is more like you're getting sodium. Okay, you're getting sodium, you are reacting with what? Oxygen. Okay, because this is what we call bonding. You are getting sodium and reacting with the oxygen. They are combining together to form what? This one, sodium oxide. Because whenever sodium reacts with oxygen, the product that we're going to have is what? Sodium oxide. Now, the point that I'm going to tell you is that before you form the ionic bonding, make sure that you form the chemical formula for those two elements that we're going to be given. So if we're given sodium and oxygen, so we need to form the chemical formula for sodium and oxygen when they react together to form sodium oxide. So we need to form the chemical formula for sodium oxide. Okay, so now sodium oxide, how do we form that chemical formula? So that chemical formula for sodium oxide, remember that sodium is what? On the periodic table, if you look at sodium, is what? Na. What about oxygen? Oxygen is what? Capital letter O. Always use what? The chemical symbols. Okay? Sodium and oxygen, they are reacting together according to what? To the question there. Now, if they react together, how are we going to get the product, which is sodium oxide? How are we going to get the chemical formula? Remember the rule. Okay? The rule is like elements from group 1 to group 4, always the valence number is equal to the what? The group number. So the rule. So make sure that you write down this rule. Okay? The rule is like this. Okay? Elements that can be found in what? Group 1 to 4. Then group number is the valence number. Very, very important point. Okay, group number is equal to the valency number. What does it mean? So if you come back here to sodium, sodium is in group what? Sodium is in group 1. Okay, if sodium is in group 1 on the periodic table, if you check your periodic table, sodium, you find out to say it will be in group 1. So if sodium is in group 1, according to this rule, the group number is the valence number. So meaning that the valence number for sodium is equal to what? 1. Is equal to 1. Why? Because sodium is in group what? 1. Okay, we go to oxygen. So if you look at oxygen on your periodic table, you find that oxygen is in group 6. So make sure that you know how to look at the group number. If you want to know about how best you can know the group number, make sure that you watch the video about the periodic table. Okay, so oxygen is in group what? 6. Now the rule changes after this. So elements starting from what? Group 5. So elements from what? Group 5 going up to group 8. What do you do? So what do you do here? You get the group, you get 8 minus group number. So here there is a formula that you can use now for you to find the variance number. Okay, the variance number, for you to find the variance number, make sure that you get 8 minus the group number for elements that are going to exist from group 5 to group 8. This is what you need to do. Okay, so now oxygen is in group 6. What are you going to do? So you're going to say 6 minus what? 80 minus group number of oxygen is what? 6. Then you're going to get what? 2. So here we're going to put what? 2 here. We're going to put what? 2 here. Alright? Then what are you going to do? You're going to cross multiply. So you're going to say this one times this one. You're going to get sodium. Okay? Then 2. Sodium 2. Then what about oxygen? 1 times oxygen. Then it will be just what? Oxygen. So this is the formula that we're going to use. Okay? So again, what is the first rule when it comes to bonding? Make sure that you write the chemical formula for the compound that you've been given, or for the atoms that you've been given. We've been given sodium and oxygen. So write the compound or the chemical formula for sodium when sodium reacts with what? Oxygen to produce sodium oxide. That's the rule. Okay? Now we need to show the bonding here. So now the bonding will be like this. So how many sodium? So now for bonding, for you to show the bonding here, make sure that you know that sodium, okay, sodium on the periodic table, you'll find out to say it's going to have 11 down there on the bottom there, which is the atomic number. Then the mass number is going to be what? 23. Always make sure that you know about that, okay? Or if you don't know these numbers, go on the periodic table, you'll find that sodium has 11 here, then it's going to have 23 as the mass number. So always we use what? This one. Always we use the atomic number. Okay? Now after forming this, what is the second step? The second step is to get what? The element that you have there, then you look at the what? The atomic number. Okay? So here we're saying this is the first step, forming the what? The chemical formula. The second step is now doing this. This is the second step that you need to do. Okay? Now, the second step that we are going to do is you need to write the electronic configuration for sodium. Okay? Electronic configuration for the elements that you have here, because it will help you to write all the atomic structures that are there and show in the ionic bonding. Okay? So this is the second step that you need to do now. Electronic configuration. We're going to get 11 here for electronic configuration, which is this one, atomic number. So we always get the atomic number for electronic configuration. Okay? So atomic number. So we're going to say now, remember, electronic configuration, we're going to have, in the first shell, we're going to have what? 2. Okay? In the first shell, we always what? Get 2. Then since from 11 we've gotten 2, what is left from 11? We have now 9. Okay? What is left from 11? If you remove 2, it is 9. So from 9 now, we can remove what? 8. Because in the second shell, we need to get about 8 electrons. So mean that we can get 80 from 9, so that now we can remain what? With what? 1. Okay? Now that one that we have here, we can just put it there, so that now we have the electronic configuration for sodium. Now, if you want to confirm your answer here for electron configuration, I'm going to say 2 plus 8 plus 1. It has to give you the atomic number, which is 11. If it gives you 11, then you are correct. Alright? So this is the second step. Second step, write the electronic configuration. Okay? Then after that, now we need to now write the atomic structures. So what is the third step? The third step is now writing the what? Atomic structures. Okay? Atomic structures. For what? For sodium and what? Oxygen. Okay? So I will talk about why it is important, these two. Why it is important. Okay, I will look at that. Okay? So we have now atomic structure for sodium now. We're going to have, remember that in the first shell, so this is the first shell. In the first shell, we're having about what? 2. Okay, in the first shell, how many are we using? We're having about 2 what? Electrons. Okay, this is the first shell. Then what about the second shell? The second shell, we have the second shell and the what? Last shell, like that. Okay, so in the second shell we have about 80 electrons. So you write 80 electrons like that. 4, 5, 6, 7, 8. And in the last shell we have only what? 1. This is for what? For sodium. So let us move these 3 a bit. So now this is for what? Sodium. So you can write sodium. So this is for what? This is for sodium. So you can write sodium, the chemical symbol there. That is for what? For sodium. Okay? Now, you need to ask yourself to say, how many sodium do we have? We have, if you come to the chemical formula, no wonder chemical formula is important, because it's going to tell you how many atoms that you are going to write for that particular atom. Okay? For sodium, it is 2. So mean that I'm going to write the sodium atomic structure. It will come twice. Okay? So I'm going to write another one. Just the same thing that I'm going to write. Like this one, the one that I wrote here. I'm going to write it here as well. So I'm going to say, that's the same thing. Okay? In the first shell, we had 2. In the second shell, we had about what? 8. And in the last shell, we had about what? 1. And this is for, again, sodium. Why representing sodium twice? Because we have what? 2 sodium. Okay? We go to oxygen. Oxygen now. Oxygen, do we know anything about oxygen? So we do the same thing for like under rule number 2. Okay, or step number 2. Like we did for sodium, we're also going to do for what? Oxygen. So I'm going to write again for oxygen here for rule number 2. Okay, rule number 2, what did we say? We need to know the atomic number for oxygen and the mass number for oxygen. So on the periodic table, if you go, you find out to say oxygen is 8 and on top is what? 16. Alright? Then what is the next step that you need to do? You're going to write the electronic configuration. So electron configuration for oxygen is what? 2, as you can see, if you remove in the first shell 2, then you're going to remain with what? 6. Then here 6 is less than 8. So remember that in the last shell we need to put about 8, but 6 is less than 8. We can just put 6 there. Okay? To confirm your answer, what did I say? You say 2 plus 6, you're going to get what? 8, the atomic number. That's what we did. Okay? Then after that, what are you going to do? We're going to write the atomic structure for oxygen using the electronic configuration for oxygen. So I'm going to say in the first shell, we have this is the first shell, and this is the last shell, which is where there is 6. So we only have 2 shells. Okay? Then we are going to have 1, 2. So here we're going to use other symbols because they said from this question we're going to have the star and the dash. Okay? So here I'll be using these 1 2 1 2 3 4 5 6, if you remember. Okay, so this is 6 for what? Oxygen. Okay, this is 6 for oxygen. So now we are done with oxygen. Remember that this is oxygen, so always make sure that you remember you put what the element that is there. Okay, now next thing that you need to understand, okay, what is happening. So what is happening here is that this sodium, remember that sodium is a metal. Sodium is a metal. They are going to start losing electrons, okay? They always lose the electrons in the last shell. Make sure that you understand. Because this is what we call an ionic bonding. Remember that ionic bonding is going to exist between a metal and a non-metal. So this is ionic bonding. If you go back to ionic bonding, what did we say? Type of bonding where a metal atom loses electrons. So if a metal atom, which is sodium, it is here, we need to make sure that this sodium loses electrons. But where are those electrons coming from? Always go to the last shell. So in the last shell here, how many electrons that are here? There is just one. So this sodium is going to lose what? One electron. Why? Because in the last shell, there is just one electron. So this electron will go here. So this electron will come here. Okay? This electron will come here, like that. So I'm just showing, you don't have to show this. I'm just showing to say this electron is moving out from this part, last shell, then going to oxygen. Again, for this sodium, we have this electron. So this electron will move out as well, and it will go to what? This sodium, like that, okay? As you can see. Now, the concept that you need to understand here is that if the electrons in the last shell for this sodium, they are moving out. So meaning that if they are moving out here, there will be no electron. Also here, there will be what? No electron. Okay? So which simply means that in the last shell here, there will be nothing. If there will be nothing in the last shell, what do you think? You remove the last shell. Because there is nothing in the last shell, everything has gone to the non-metal, which is oxygen. So remove the last shell. Also here, remove the last shell so that you see what is happening. Because that last shell, there was nothing, there were no electrons. So you don't have to write it. Okay? Now, to show, since I said these arrows, we don't have to write them. So you need to remove the arrows, because if you show the arrows that this is giving one electron, you're going to get it wrong, or you are going to get it wrong or low marks. They don't allow showing arrows. Okay, so they only allow something like this. Then to show now, instead, since you are not using arrows, now to show that this sodium has lost one electron, because this sodium was losing one electron, what are you going to do? You are going to make sure that you respect that. Okay, me, I'm not going to show arrows, but I'm going to show something that this has lost one electron. One electron, it means positive. Okay, positive. One electrons, it means what? Positive. One positive. If sodium was losing two electrons, I was supposed to put it 2 plus, like that. Now, since it is losing one electron, I'm going to say positive. Okay. Same applies here. I'm going to use these large brackets here. Okay, to respect that. Since it is losing, I'm going to put what? Positive. Okay, I'm going to put positive. Now, again, you do the same thing to what? Something that is receiving, which is a non-metal. So also respect that, okay, this non-metal is receiving 2 electrons. As you can see, this non-metal is receiving this electron from this, and this non-metal is receiving what? This electron from another sodium. Also, you respect that. Respecting means that you put in brackets and you show the examiner that this oxygen is receiving what? Electrons. Okay, how many electrons? 2. Now, the point that you need to understand is that if I write 2 here, you don't have to put a positive sign. Positive signs mean that you are giving. Negative sign means that this is receiving. So you put a negative. Why? Because oxygen is what? Receiving how many electrons? 2 electrons. Okay, so in short, the other thing that you can do here is that apart from doing that, this is now complete, then you are going to get the full 4 marks. Okay, you are going to get this, or 3 marks. Okay, this is how you do it. Now, the other important concept, another important thing that you need to understand about this one, make sure that you write this. Okay, good example. Then we need to write another good example apart from this. Last good example. Okay, last good example that we need to look at now. Okay, number 2, we are going to show the bonding between, okay, calcium and chlorine. Okay, let us just use between calcium and let us use another one apart from chlorine. Let us use maybe sulfur. Or let us just use chlorine, the famous one. So, and chlorine. Okay, so show the bonding between calcium and the chlorine. What is the first thing that we need to do? So this is the last example that we're going to go through. Okay, show the bonding between calcium and chlorine. So the first thing is to identify what type of bonding is this. The type of bonding of this is what? Since there is a metal and a non-metal, chlorine is a non-metal, calcium is a metal, meaning that this is what we call what? This is an ionic bonding. Okay, so ionic bonding, what was the first rule? First rule, make sure that you write the what? The chemical formula. So how do we write the chemical formula? So calcium always start with a metal. So I'm going to write calcium. Calcium on the periodic table, you find the symbol, chemical symbol, which is the Ca. Okay. Then calcium is reacting with what? Chlorine. Okay. Calcium is reacting with what? Chlorine. So let me use this. Calcium is reacting with what? Chlorine, like that. Okay, like that. Now remember the rule that we talked about. We said for you to write numbers here, make sure that you know the group number for calcium as well as the group number for chlorine. Okay, now what is the group number for calcium? Calcium is in group 2. So remember that rule, we said group number is the valence number. If calcium is in group 2, then the valence number will be what? 2. Alright, what about chlorine? Chlorine is in group 7. If you check chlorine on the periodic table, you find out to say it is in group 7. What did we say for group 7? Or for groups starting from 5 going above? We are going to say group number. Okay, we are going to say 8 minus group number. Then the group number for chlorine is 7. Then the valence number is what? 1 if you try to subtract. So chlorine is going to have 1 valence number. Okay, so what are you going to say? Then you cross multiply. You're going to cross multiply this one and that one. You're going to have calcium. Okay, like that. Then 2 times chlorine, you're going to have like that. Okay, calcium chloride, like that. So this is now what we call calcium chloride. That's the first step that you need to remember. Okay, you make sure that you write the chemical formula. Okay, then what is the second step? The second step that you need to remember is what? Write now the electronic configuration. How do you write? So if you look at calcium, we'll start with calcium. Okay, calcium on the periodic table, it has 20 here and it has 40 there. So make sure that you know the periodic table. So if you look at calcium on the periodic table, you find it has an atomic number of 20 and it has the mass number of what? 40. So we always use what? The atomic number for electronic configuration. So what is the electronic configuration for calcium? We're going to say in the first shell, we're going to remove what? 2. Then This is now remaining. What is remaining here is what? 18. From 18 we can remove what? 8, so that we can remain with what? 10, because 18 minus 8 it is 10. Now from 10 we can remove 8, so that now we remain with what? 2, because 10 minus 8 it is what? 2. Now 2 we can't remove 8, we just have to write what? 2 there. Okay, so this is the electron configuration for what? For calcium. Now if you want to confirm, remember what I said, you need to add 2 plus 8, 10, 10 plus 8, 18, 18 plus 2, it is what? 20. Then you are correct. Okay. Then you do the same thing with the chlorine. So chlorine, if you look at on the periodic table, so on the periodic table it has 17 and 35.5. Okay. So this is chlorine. Now we use what? The atomic number. So now the atomic number for chlorine is 17. Now what about the electron configuration? Remember, in the first shell we are going to remove 2 from 17. Okay, and we are going to remain with what? We are going to remain with 15. Now we can remove 8 from 15. Okay, so that we remain with what? We remain with the about which is 7. Okay, now this 7 we can just put it here because it is less than what? 8. So this is the this is what we call the electron configuration for chlorine. It is 2 plus 8, 10. 10 plus 7, it is equal to 17. Make sure that you know that. Okay. Now this is the second step. What is the third step? The third step now is this one. Okay. The third step is this one. The third step is that we are going to write the atomic number or the atomic structure of calcium and the chlorine. Okay. So I'm going to use this one. So I'm going to say in the first shell. So how many shells do we have here for calcium? Okay, so we have about 1, 2, 3, 4. So I'm going to write about it for 2, 3, and the last one is what? 4 right there. Okay, I'm going to use red for this one. So in the first shell we're going to put 2. In the second shell we're going to put 8. 1, 2, 3, 4, 5, 6, 7, 8. In the third shell there is also 8. If you look at there, so put 8 again. Then in the last shell there are what? 2. Like that. 2 electrons. This is for what? Calcium. Okay. What about chlorine? Chlorine, it has how many shells? 1, 2, 3. So it has 3 shells. So we're going to write 3 circles. 1, 2, 3. Okay. Then for this chlorine, we're going to use the dot diagram. Since here we use the star symbols, so here we're going to use the dot. So I'm going to use red again. So 1, 2. In the second shell, we're going to have 8. Then in the last shell, we're going to have 7. 1, 2, 3, 4, 5, 6, 7, like that. This is what? Chlorine. Now, remember, if you reach this part, now you need to ask yourself, how many atoms that are there? If you come for calcium, you go to the what? You use now the what? The chemical formula. So the chemical formula for calcium chloride, we only have 1 calcium. So calcium is just going to be like this, just 1. But what about chlorine? Chlorine we have what? 2. So I'm going to write another chlorine molecule here because we have 2 now, according to the chemical formula. Okay. So we have 2. So I'm going to say 1, 2, 1, and 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6. Then in the last cell we have what? 7. Just the same thing. Okay. Chlorine, like that. Okay. Now, since we have 2 chlorine molecules according to the what? Chemical formula, and we have 1 calcium. Then you go back to the definition of ionic bonding, Ionic bonding means that a metal, which one is a metal between calcium and chlorine? It is calcium. So calcium is the one that's going to lose electrons. Okay. Now here is something is tricky. So how many electrons are in the last shell? Because I said in the last shell, that's why we transfer or we get electrons. Okay. Now how many electrons are in the last shell? They are about what? 2. And there are 2 chlorine molecules here, meaning that calcium is not that stingy, meaning that it's going to give 1 electron to this one and 1 electron to that one. Don't just give 2 electrons to this one. No. Now, where is the other electron to make sure that this other chlorine molecule is going to be stable? So make sure that you divide this into what? 1, 1. Okay? So I'm going to get 1 here to give this one, and 1 here to give what? This one, so that it is equally distributed. Okay, that's what you need to do. The next thing what I said is that since we are giving out these electrons in the last shell, for a metal you need to remove the last shell. Now since there is nothing left, since all the electrons have been given out or transferred, meaning that we don't have to write the last shell. Okay, so now we're going to respect this. Remember what I said, for you to respect that you've given out the electrons, okay, make sure that you respect it using what? The bracket. Now ask yourself, how many electrons does this calcium atom loses or lost? That is what? 2 plus. So remember what I said, losing is what? A positive number. A positive number. Yeah. So if calcium is losing, meaning that you are going to have what? Positive. How many electrons have been lost by calcium? It is 2. Okay. Now what about this? These also they are receiving, so respect them as well by doing like this. You respect them like that. Okay. Now how many are they receiving? This one is just receiving 1, so I'm going to put a what? The negative there, because 1 means just negative. Also this one is just receiving 1, so you put a negative. Receiving is negative. Okay, so this is all about the ionic bonding. The last part is talking about what now? The properties of ionic bonding. So make sure that you write this. All right, so the properties. So properties of ionic bonding. Okay, properties. So what is the property or the properties of these ionic compounds that are going to be produced? What are the properties? Because they like asking questions like this. What are the properties? So the properties of these ionic compounds that are going to be produced is that the first one is they conduct what? Electricity. Conduct electricity in molten state. Okay, they conduct electricity in molten state. What does it mean when you say molten? It means that it's something that is in liquid form. Okay, ionic compounds, they do not conduct electricity in solid state. They only conduct electricity in liquid form or in dissolved form. Okay, that's when they can only produce or conduct electricity. So that's the first property. Okay, what's the second property? Is that, as you can see, it has different charges. So you are going to say contains different charges. Okay, number 3. Okay, another important concept, apart from having positive and negative contain different charges, they've got what? High melting and what? Boiling points. Why is it like that? It is because of this. If something is having negative charges or opposite charges, which is positive and negative, what do you think to the force of attraction? The force of attraction is going to be higher. If that happens, means that for you to melt that substance, it will take what massive amount of heat. So meaning that you are going to have high melting point and what high boiling point. And this is where now we end from in this video. Make sure that you stay tuned. In the next video, we'll talk about what covalent bonding. All the best until next time.